Hello, I'm ETarte, math teacher. I have a solution video for my math challenge entitled Going Off on a Tangent. In that challenge we had two equal circles, each with radius length 1, tangent to each other. Here's the point of tangency. And we had this horizontal line going through the center of each circle, and that also makes it go through the point of their tangency. And we also had this slanted line intersecting the left-hand circle and the horizontal line, both at the same point. And this slanted line is tangent to the right-hand circle at point B. It intersects the left-hand circle at point A. And again, assuming that the radius of each circle is length 1, the question is, what is the length exactly of segment AB? Well, here's my solution. I call this point of intersection C. I call the center of the left circle D, the center of the right circle E. I connect E to this point of tangency B by a fact of geometry that makes this a right angle. I also connect the center D to the slanted line, that point of intersection being F, and I make this perpendicular. That, by a fact of geometry, splits CA into two equal parts, so CF and FA are equal to each other. Now consider right triangle CBE. CE is the hypotenuse. Its length is 3 radii, each with length 1, so the length of the hypotenuse is 3. The length of this leg is 1 radius, which is 1. And we can use the Pythagorean equation to find the length of the other leg, CB. By the Pythagorean equation, I have CB squared plus BE squared equals CE squared. BE is 1 and CE is 3, so we have CB squared plus 1 squared equals 3 squared. That's CB squared plus 1 equals 9. I subtract 1 from both sides of the equation, and I now have CB squared equals 8. So the length of CB is the square root of 8. Now that's using right triangle CBE. The smaller right triangle CFD shares with the larger right triangle the angle at C. That means the smaller right triangle is similar to the larger right triangle, and that means its sides are proportional. Well, its hypotenuse is 1 compared with the hypotenuse of the larger right triangle, 3, so that's 1/3, so the proportion is 1 to 3. So that proportion must also hold for this leg. And since this leg of the larger triangle is the square root of 8, the leg CF of the smaller triangle must be 1/3 the square root of 8. But as I said earlier, F splits CA in half, so FA has the same length as CF. So FA also is 1/3 the square root of 8. And that means we have thirds here for the entire segment CB. 1/3 of the length, another 1/3 of the length, and the remaining 1/3 of the length. So AB also is 1/3 the square root of 8. And so that is the answer to the question of this challenge. Thank you for watching this solution video.